So let's start with our first derivation, that is refraction at spherical surfaces. Refraction at spherical surfaces. So basically what is happening in refraction at spherical surface is, you have a spherical surface like this. Let me cut it from one side because it's only a single surface, one side surface. This is a spherical surface. And let's say this is a ray which is passing through the geometrical center of the spherical surface. Okay. So let me make it a little up here. Okay. Let's say on this spherical surface there is one object which is placed, and let's say this object is placed at O, and when it is going, this is N1 and this is N2, provided N2 is greater than N1. This will be used in the next derivation, that's why. N2 is what? Let's say glass. N1 is what? Let's say air. So light rays are going from air to glass, and when they are heading, they are going this side, and this will make a here and final image I. Let's draw a normal. So normal will be perpendicular to this surface, and it will go and hit on the principal axis at which point? Always at the center of curvature. So center of curvature rays are like this, we know that. They are like this, going and passing. Okay, they go undeviated. This is, and they fall on the surface perpendicularly 90 degree. This is center of curvature. Now before we proceed to this, there are few assumptions we have to keep in mind while solving. First assumption is, for small angle approximation, tan theta will be always nearly equal to theta if theta is less than 10 degree. So if angle is small, tan theta is nearly equal to theta. First thing. Second thing, if I make a perpendicular, if I write it as M and N, and if I make a perpendicular from here, okay, this is my perpendicular here, and let's call it as P, then we will say that NP is negligible, and MN is perpendicular to the principal axis. These are the assumptions you have to keep in mind to understand this. Okay. So if Mn is perpendicular, let me remove this P to avoid any confusions. So Mn is basically a straight line. Mn is a straight line. And if Mn is straight line, then let's take our triangles. So let me take my first triangle, triangle MNO. I hope you can locate it. MNO. In this triangle, tan of angle MON. Why sir tan? Because I have assumed that MN is perpendicular. If it is perpendicular, then MNO is a right angle triangle, and for right angle triangle we can use trigonometric identities. So tan of MON, that will be equals to MN upon ON. What is that? Perpendicular over base. Let's take another triangle, triangle MNC, that will be equals to tan of angle MCN, that will be equals to MN upon base is NC. Finally, the next one is triangle MIN, and that will be tan of angle MIN, that will be MN upon NI. I hope this is clear. Now, from small angle approximation, tan theta will be nearly equal to theta, so angle MON will be MN upon ON. MCN will be equals to MN upon CN. And finally, MIN will be equals to MN upon IN or NI. This is our equation 1, this is our equation 2, this is our equation 3. Now we know that refractive index mu by Snell's law, sin I upon sin R. And refractive index mu is nothing but the ratio of N2, the second medium, upon the first medium. So if we cross multiply, it will be N2 sin R is equals to N1 sin I. Sir, what are I and R? I is the angle of incidence. What is angle of incidence? The angle made by the incident ray with the normal. And what is R? Angle made by the refracted ray with the normal. So this is R in the diagram. Once you made it, let's apply small angle approximation for sine also. So this will be N2R, which will be equal to N1I. Equation number 4. Let's move ahead. Now, if I take the triangle MOC, in the triangle MOC, I hope you can locate it. Angle I is the exterior angle, that will be the sum of MCN plus MON. MCN, okay, we'll substitute it later. So let me place it here as equation number 5. And in triangle MIN or MIC, let me take it as MIC. I hope you can locate the triangle MIC, that small triangle over here. Angle MCN is the exterior angle, and that will be equals to angle R plus angle MIC or MIN, you can say. So angle R will be equals to angle MCN minus angle MIN. That's equation 6. We got our I and R from 5 and 6. Yes. Can we substitute it in equation 4? Yes. So N2 into R. R is angle MCN minus angle MIN equal to N1 into I. I is MCN plus MON. Can we substitute the value of MCN and MIN? Yes. From equation 1, we can substitute the values. So let's substitute here N2 into MCN, MN upon CN minus MIN, MN upon NI. That will be equals to N1 into MCN, MN upon CN, MON, MN upon ON. Now let's simplify further. So if you look at this, all of them have Mn in the numerator, so we can divide the whole equation with Mn. So what we left with? N2 into 1 upon Cn minus 1 upon Ni is equals to N1 upon Cn plus N1 upon On. I hope this is clear. Let's take this N2 upon Cn on the left hand side and N1 upon I on the right hand side. Let me take. So and N1 upon Cn on the left hand side. So here when you multiply, it will be N2 upon Cn, and taking N1 upon Cn on the left hand side minus N1 upon Cn, and this N2 upon Ni on the right hand side. So N1 upon On plus N2 upon Ni. Let's go back. On, if you look at this diagram, On is nothing but your object distance. So if you are sitting at the pole of this surface, this will be on the left hand side. So minus U. NC or Cn is the radius of curvature, which is lying on the right hand side. So positive. And Ni is nothing but the image distance, that is again lying on the right hand side. So V. If I substitute these values here, it will be N2 upon R minus N1 upon R equals to N1 minus N1 upon U. Why negative? Because On is the object distance, that is negative, and plus N2 upon V. So this we can write it in the standard form, n2 upon v minus n1 upon u is equals to n1 it is. n1 upon u equals to n2 minus n1 upon r. This is very, very important relation for solving problems. This is called. Okay, so when do we use this relation? That is very important. If you are given with the radius of curvature of a spherical surface along with the two different refractive indexes, then you use it. Otherwise, we have two other options which are 1 by v minus 1 by u equal to 1 by f. That's our lens formula. And we have lens maker's formula also that we will see after this.